Okay, now I would like to explain the problems on current densities. Okay, first one, find the frequency at which the conduction current density and displacement current density are equal in a medium with sigma equals to 2 into 10 to the power of minus 4 ohms per meters and epsilon r equals to 81. Okay, here we have to find the frequency at which the conduction current density and displacement current density are equal. So conduction current density represented by Jc bar, displacement current density represented by Jd bar. So here given these two current densities are equal. So Jc bar by Jd bar equals to 1 given. So we know that the conduction current density equals to sigma into E bar, displacement current density equals to omega or epsilon into E bar. So sigma into E bar by omega epsilon into E bar. E bar cancel. So modulus of Jc bar by modulus of Jd bar equals to sigma by omega epsilon. It equals to 1. Okay, here given Jc equals to Jd. So Jc by Jd equals to 1. Jc by Jd equals to sigma by omega epsilon. Or omega equals to sigma by epsilon. Given sigma equals to 2 into 10 to the power of minus 4. So next epsilon equals to epsilon naught into epsilon r. Epsilon naught value constant value. It equals to 8.854 into 10 to the power of minus 12. And epsilon r equals to 81. So omega equals to 0.2788 into 10 to the power of 6 radians per seconds. Here omega is angular frequency. So frequency equals to omega by 2 pi. Omega formula 2 pi f. So f equals to omega by 2 pi. Omega by 2 pi. So omega equals to 0.2788 into 10 to the power of 6 divided by 2 pi. So finally the frequency equals to 44.372 kilohertz. Okay, Jc means conduction current density, Jd means displacement current density, Jc bar equals to sigma into E bar, Jd bar equals to omega epsilon into E bar. So Jc bar by Jd bar equals to sigma by omega epsilon. Okay, next problem. For a lossy dielectric, sigma equals to 5 Siemens per meters and epsilon r equals to 1. The electric field intensity is E equals to 100 sin 10 to the power of 10 into t. So find JCJD and frequency at which both have equal magnitudes. So here given E given, sigma and epsilon r. So we have to find Jc. Jc means conduction current density, Jd means displacement current density. So next frequency at which have equal magnitudes. So first find Jc. Jc equals to formula sigma into E bar. So given sigma equals to 5, E equals to 100 sin 10 to the power of 10 into t. So Jc equals to 5 into 100 sin 10 to the power of 10 into t, or 500 into sin 10 to the power of 10 into t, amperes per meter square. So current density units are amperes per meter square. So next displacement current density formula, Jd bar equals to dou by dou t of d bar, or omega epsilon into E bar. Okay, it equals to dou by dou t, d equals to epsilon into E, or it equals to dou by dou t epsilon naught into epsilon r E bar. So epsilon naught epsilon r constant, Jd equals to epsilon naught into epsilon r dou E by dou t. Epsilon naught equals to 8.854 into 10 to the power of minus 12, epsilon r equals to 1. Here given epsilon r equals to 1. So next dou by dou t of E bar. So E bar equals to 100 sin 10 to the power of 10 into t. So by differentiating this one, we get 8.854 into 10 to the power of minus 12 into 10 to the power of 10, 100, differentiation of sign, cos 10 to the power of 10 into t. At Jd equals to 8.854 cos 10 power 10 into t, amperes per meter square. So for the two current densities, we have to find the frequency at which these two current densities are equal. If these two current densities are equal, the ratio equals to unity. So modulus of Jc bar equals to modulus of Jd bar equals to 1. In this case, we have to find the frequency. So Jc bar by Jd bar, we know that sigma by epsilon into omega. Omega equals to sigma by epsilon. So given sigma equals to 5, epsilon equals to epsilon naught into epsilon r. Here given epsilon r equals to 1. So epsilon naught equals to 8.854 into 10 to the power of minus 12. So omega equals to 5.641 into 10 to the power of minus 11. We know that omega equals to 2 pi f. So f equals to omega by 2 pi. Substitute omega value here, 5.647 into 10 to the power of 11 by 2 pi. So finally frequency equals to 89.877 gigahertz. So in this problem, so we have to find the conduction current density. The conduction current density formula sigma into E bar. Next one, displacement current density. Displacement current density JD bar equals to dou by dou T of D bar. So next we have to find the frequency at which the conduction current density and displacement current density are equal. If these two current densities are equal, the ratio equals to unity. The ratio equals to sigma by omega epsilon. So by using this formula, so we can find first omega. First to find omega value. So next by using the relation omega equals to 2 pi f, we can find the frequency. So here frequency equals to 89.877 gigahertz. Okay, next problem. A lossy dielectric has mu equals to 4 pi 10 to the power of minus 9 henries per meters and epsilon equals to 10 to the power of minus 8 by 36 pi farads per meters. Sigma equals to 2 into 10 to the power of minus 8 siemens per meters. The electric field E bar equals to 200 sin omega t A Z bar volts per meters exists at a certain point in the dielectric. So first one, at what frequency? So will conduction current density and displacement current densities have equal magnitudes. So next, at this frequency calculate the instantaneous displacement current density. So next one, what is the phase angle between the conduction current and displacement current? So here first one, we have to find the frequency at which these two current densities are equal. So if these two current densities are equal, the ratio equals to 1. So use formula JC by JD bar equals to sigma by omega epsilon equals to 1. So omega equals to sigma by epsilon. Here given sigma equals to conductivity 2 into 10 to the power of minus 8 and epsilon equals to 10 to the power of minus 8 by 36 pi. So omega equals to 226.194 radians per seconds. So omega equals to 2 pi f. F equals to omega by 2 pi. So substitute omega value here, 226.194 divided by 2 pi. So it equals to 36 hertz. So here frequency equals to 36 hertz. At 36 hertz, in this case the conduction current density and displacement current densities are equal. So next one, so find instantaneous displacement current density. So now we have to find the displacement current density at this frequency. So displacement current density JD bar equals to formula dou by dou T of D bar and D bar equals to epsilon into E bar. So JD equals to dou by dou T epsilon into E bar. So epsilon equals to given 10 to the power of minus 8 by 36 pi. Epsilon equals to total value 10 to the power of minus 8 by 36 pi. So dou by dou T and given E bar equals to 200 sin omega t. So it equals to 10 to the power of minus 8 by 36 pi into 200 sin omega t differentiation cos omega t into omega. So it equals to 10 to the power of minus 8 by 36 pi into 200 into 2 pi f. Here f equals to 36 into cos 2 pi f into t. Omega equals to 2 pi f into t. So equals to 400 into 10 to the power of minus 8. So cos 72 pi t amperes per meter square, or it equals to 4 into cos 72 pi t microamperes per meter square. So next one, conduction current density. So third case, what is the angle between conduction current density and displacement current density? So third one, JC equals to sigma into E bar and JD equals to epsilon into d by dt of E bar. So from the JC/JD, it is clear that both are always at right angles to each other. So the phase angle between the current density is equals to 90 degrees. So always the capacitor current and the resistor currents angle difference equals to 90 degrees. So here also same. So JC equals to sigma into E bar. So sigma into E bar equals to 200 sin omega t. Here omega equals to 2 pi f. So 72 pi. So 200 sin 72 pi t. Sigma into 200 into 72 pi t, and it is cos 72 pi t. So the angle difference equals to 90 degrees. So here the angle always generally the angle difference between conduction current density and displacement current density equals to 90 degrees. So displacement current density means the capacitor current density, conduction current density means the resistor current density. So always the currents in resistors and capacitors, the angle difference equals to 90 degrees. So current density is also the angle difference equals to 90 degrees. Okay, next one. So find the displacement current density within a parallel plate capacitor having dielectric with epsilon r equals to 10, area of plates A equals to 0.01 meter square, distance of separation D equals to 0.05 millimeters, applied voltage equals to 200 sin 200 t. So we know that the current through the parallel capacitor equals to formula I equals to C into dV by dt, and C equals to epsilon into A by D dV by dt. Here epsilon equals to epsilon naught into epsilon r. So epsilon naught into epsilon r A by D dV by dt. So now substitute values: epsilon naught, epsilon r, A value, D value, and V value. So IC equals to first epsilon naught equals to 8.854 into 10 to the power of minus 12. So next epsilon r equals to 10. So given area equals to 0.01 divided by D. D equals to 0.05 millimeters. So 0.05 into 10 to the power of minus 3 d by dt. V equals to 200 sin 200 t. So capacitor current IC equals to 0.7083 into 10 to the power of minus 3 cos 200 t amperes. Okay, you know that the current in a capacitor is called displacement current. So we can write IC equals to ID. So next find the displacement current density. Current density equals to current by area. So JD equals to current by area. Here ID equals to this one, area equals to 0.01 given this value. So finally JD equals to 0.7083 into 10 to the power of minus 3 cos 200 t divided by 0.01. So displacement current density equals to 70.83 t into 10 to the power of minus 3 cos 200 t amperes per meter square. Okay, here we have to find the displacement current density by using these values. So first to find displacement current. So displacement current is nothing but the capacitor current. Capacitor current formula I equals to C into dV by dt. C equals to formula epsilon into A by D. In case of parallel plate capacitor, C equals to epsilon into A by D. So by substituting all these values, so first to find IC value. So here this is the IC. So this equals to displacement current ID. Next to find the displacement current density, current by area. So finally the displacement current density value 70.83 t into 10 to the power of minus 3 cos 200 t. So units are amperes per meter square.